Hello, and thank you for joining us today. My name is Kobi Magnezi. I'm product manager for GKE. And I have the pleasure to have here with me today Donovan Carter, senior DevOps engineer at Dexcom.
Thanks, Kobe. It's a pleasure to be here. As Kobe said, my name's Donovan Carter. I'm a senior DevOps engineer with Dexcom. I've been working with Dexcom and the DevOps team on our platform team for the last 3 years, and it's been a joy and an honor to get to know Kobe through our mutual love and interest of Google Kubernetes Engine, which we're here to talk to you today about.
Awesome. So we are here to share with you some of the best practices that you can follow to achieve high availability and business continuity with GKE. But first, let's define what business continuity means. Business continuity means having a proper plan, preparation, and mitigation strategy in place. So, in case something happens with the potential to disrupt your business, your organization will have the ability to sustain its critical application. We'll break this discussion to two parts, day zero and day two. And for each one, we'll provide some key recommendation.
And my context on this is to discuss how Dexcom leverages this business continuity approach. For those of you who may not be aware, Dexcom is a industry leader in the continuous glucose monitoring space. What that means is for people with type 1 diabetes, we give them a platform of services that they can use to both keep in touch with their own disease or the disease of a loved one, as well as far as monitoring levels of their actual blood glucose. Because of that, we have chosen Kubernetes and Google Kubernetes Engine specifically because, with the needs of our customers being what they are, we have to provide that service to them in a highly available way. And so the obvious choice was to go with Google Kubernetes Engine.
So, can you share more, Donovan, why you decided to use a managed service instead of using your own Kubernetes and install it on your environment?
Absolutely. It comes from experience. We were using another cloud provider prior to our migration to Google a few years ago. And on that cloud provider, we had made the decision to essentially deploy our own Kubernetes service within the cloud. What we found out is that it's really hard to do that. It requires a lot of operations, and we're going to get into that today. And we decided not to invest some of that toil, the monitoring, the alerting, all of the things that go into running your own Kubernetes, which you can do because Google presented itself as not only an industry leader and a contributor to the Kubernetes project, but also provides it as a managed service, which to us and the things that we have to deal with on a day to day was very, very attractive. And so far, we've been really, really excited about that. The other added bonus is that it scales. It scales ridiculously well, and we don't have to do anything. We don't really have to think about it. It's been a life changer for us to go from where we were several years ago to where we are now, and it's exciting to see where we're going to go in the future.
Awesome. So let's look at several recommendations we have for day zero. And when thinking about high availability of GKE cluster, it is important to carefully plan the topology and configuration of your GKE cluster before you even deploy your workloads. Let's look quickly on the GKE architecture and main components. When you provision a new Kubernetes cluster, GKE provisions the machine, the underlying GCE resources that are required for the control plane and the nodes. We also manage the rollout of the Kubernetes version and patches and their availability in the GKE fleet. GKE manages the control plane, including all the components running on it, things like API server, etcd, and others. We also manage the software that runs on the nodes. That includes operating system, image, kubelet, and others. When you create a cluster, you can decide on the right topology for your business. You can choose to create a zonal cluster, which includes one replica of your control plane. And then you can decide whether you want to have all your nodes span across three different zones or whether you want to keep them all in one zone with the control plane. That really depends on your needs from the environment. The alternative is to create a regional cluster for which GKE provisions three machines for the control plane. And the node pools are also spanned across three availability zones. The control plane redundancy provide a high availability control plane, which in turns offer higher SLA for the Kubernetes API. Even though your business application, those that run on the nodes, will continue to run and serve traffic when the control plane is down, temporarily, for example, for maintenance, it is recommended to use regional cluster for highly available workloads. Kubernetes control plane is responsible to observe, scale, and repair your cluster. And when higher availability is required, regional cluster should be preferred. Whichever topology you end up using, GKE offers a fully managed experience for the control plane. That means that we take care of backups, repairing the control plane if something happened. We make sure it's available through monitoring, health checks, and auto repair. We also keep you up to date and we upgrade your control planes to the latest Kubernetes version and patch and security patch available in a reliable manner. And most importantly, you get Google SRE to monitor and manage your infrastructure for you. Nodes are shared responsibility. That means that while the control plane is hosted in a Google project, the nodes are run in your project, in the customer project. That being said, GKE offers a variety of capabilities that automate the lifecycle management of the nodes as well. And we'll cover those next. So now that you decided on the cluster topology, it is important to consider the scaling strategy. While scalability is important for continuity, scaling is necessary to ensure that as you grow, we match your needs. So we can grow the number of pods, the number of nodes based on demand. GKE includes several auto-scaling capabilities that allow GKE to automatically resize your cluster based on your configuration and some monitored signals. Um, Donovan, I would love to hear how Dexcom is using scaling, auto-scaling as well.
Absolutely. Dexcom's grown tremendously, and being a part of it has been an awesome experience. But part of that comes with design and planning, and specifically having to scale up resources. And being a part of a cloud provider such as Google really helps with that. Things that we don't have to think about thanks to the GKE cluster autoscaler are: do we have enough nodes for our workloads? Thanks to the GKE cluster autoscaler, that problem is solved. It brings in new nodes whenever we need them. Additionally, we've been able to leverage horizontal pod autoscaling in concert with the cluster autoscaler to provide a better quality of service to our customers during peak utilization hours. Being a worldwide company, that can be at any time of the day, depending on what region we're looking at. So having to have a person monitor that and manually intervene just doesn't make sense. We've also seen the opposite when we're at our valley utilization period. We're able to save money as well as resources for Google by scaling down to an acceptable threshold to provide the same quality of service and not use those resources, which has been wonderful.
And auto scaling really help you with scaling up and down to meet your demand. But sometimes we do need to do some capacity planning, especially when you expect some peak demand seasons like Black Friday, Cyber Monday, or New Year. In this period of time, we may want to reserve GC capacity so that when we need that capacity, for example, for scaling, repairing, or upgrading, we'll have a reserved pool of resources available for the cluster to consume. Basically, GKE reservation is an integration between GKE and GCE zonal reservation. So you can create a specific or non-specific reservation, and GKE will create new resources based on the pool reserved for you. There's an example here on the right side where we create reservation of 3 machines, we verify the reservation, and then we create a cluster to consume any matching reservation that we created. Now that we cover the provisioning and scaling of nodes, let's talk about the application, your business application, those that run on the nodes. Different applications have different behavior and needs. Some applications are stateless and some are stateful. More than 50% of GKE customers run stateful workloads on Kubernetes successfully. It's not an easy task, but luckily, Kubernetes and GKE offer configuration and tools to support different type of application. Donovan, do you guys run any stateful application on GKE?
We do, and when you say it's not easy, you're absolutely right. There are certainly things that make it difficult or more less difficult, and I think we're going to get into those here in just a second.
Exactly. And when you run different type of application, you also need to think about disruption and how you can tolerate disruption. Pod disruption budget, or PDB, allows you to state your disruption tolerance. In other words, if your application is, let's say, replicated, you can specify how many replicas you are willing to sacrifice when voluntary events like upgrade happens. In this example, on the right side here, we specify that we cannot tolerate less than 2 replicas of our application. This is just another way to say max unavailable equal 1 if you have 3 replicas and you want only 1 to be unavailable. Um, GKE respects PDB up to 60 minutes and also termination grace period up to 60 minutes. So that's 2 hours in total. As I mentioned, PDB covers voluntary events like upgrades or repair. As you can imagine, if there is a failure of the physical machine, for example, PDB clearly won't be able to mitigate that. The other thing you want Kubernetes to know about your workloads is whether you would benefit from collocating some of your pods on the same machine. Or maybe actually, if you do so, if you do collocate some of the pods on the same machine, you run into risk. Kubernetes scheduler automatically spreads your pods across nodes. However, sometimes, for example, let's take a stateful application like Redis or Zookeeper, a quorum of servers is required to successfully commit mutation to data. By default, Kubernetes may decide to collocate pods in stateful set on the same pod. However, for business continuity, we want to make sure that collocated pods don't present the risk of single point of failure, right? So if we have stateful set, we can use pod anti-affinity, for example, to make sure that Kubernetes don't schedule more replicas on the same machine. So each replica gets its own machine. On the flip side, some application may benefit from actually being collocated. For example, let's say you have a web server and a cache service. You want them to be on the same machine for better performance and low latency. Donovan, are you guys using any pod anti-affinity or affinity with your application?
Yeah, it's exactly like you said, Kobe. We want to make sure our sensitive workloads aren't exposed to single points of failure, stateful sets specifically, but also we use preemptible nodes. And as you know, preemptible nodes only last for a max of 24 hours. So we want to make sure that our highly available workloads are truly highly available and not subject to single points of failure. And free bonus content, preemptible nodes are a great way to find out if your workload is really susceptible to that or not.
Right. And before we move to cover day two, there is one more important aspect of business continuity, and it's about having accurate signals. So Kubernetes know exactly how your workload should behave, and it can accurately monitor the health and the state of your workloads. The first one is readiness probes. If your application, for example, takes some time to start, to initiate, you don't want Kubernetes to start sending customer traffic to that workload until it's fully ready to serve traffic. You do so by setting up the readiness probe. The other important signal is liveness. Is your workload healthy and live, or does it require a repair? Setting this probe can provide better signal to Kubernetes and also avoid false positive cases in which Kubernetes will try to repair unnecessarily. So now that we set up the cluster, let's cover several recommendations for day two. So one of the most important things you need to carefully plan for day two is your upgrade strategy, and specifically a plan to continuously upgrade your cluster. That's because Kubernetes minor version is released roughly every 3 months from open source, and a patch version may be released every month. Because Kubernetes run on both the control plane and the nodes, there are basically two places to manage when it comes to managing versions. And there are many reasons why it's crucial to keep your cluster up to date. Among others is support, right? Supported versions are get regular updates and security patches, and we oftentimes cherry pick fixes from one supported version to another. Kubernetes releases a new minor version every 3 months, and it supports up to 2 minor version back. That translates to roughly supporting each minor version for about 9 months. One important thing to call out is that an open source announced that with Kubernetes 119, 119 will be the first release to officially receive a year of patch support. So effectively prolonging the support period from 9 months to 12 months for Kubernetes minor version. The other requirement is to maintain supported version skew between your control plane and the nodes. Nodes cannot run newer version than the control plane, and they have to be within 2 minor version from the control plane. So, for example, if your control plane runs on 119, your node pools can run 119, 118, or 117, the currently supported versions. Since GKE automatically upgrade the control plane in the fleet, it is recommended to use auto upgrade or at least have a plan to manually upgrade nodes on a regular basis. This way, you'll avoid getting into an unsupported version skew situation with the upgraded control plane. If you do decide to manage your own upgrade workflow, you also want to make sure that your upgrade strategy support any compliance that your workload may be subject to. There are different compliance, PCI, DSS, SOC 2, and HIPAA that Dexcom is following as a medical devices company. Each one of these compliance has actually specific section that speaks about how fast you should consume critical patches. So you definitely want to take a look into this compliance and make sure that your upgrade strategy follow the compliance. In GKE, we offer fully automated process to upgrade both control plane and nodes. Control planes are managed and by Google, and we initiate their upgrade as part of our GKE release. Your business application, the workloads running on the node, stay up and running when we upgrade the control plane. And during the control plane upgrade, you are unable to change the cluster configuration for several minutes because we are taking the control plane down while bringing a new one. So when we upgrade zonal control plane, we do it by creating a new control plane with the new version. Then we move the network and the disk over and delete the old control plane. Regional control planes are upgraded in a similar fashion, but you get the redundancies of 3 control planes. So you always have 2 control planes available when we upgrade one at a time. Node upgrade can be automated as well, and we strongly recommend you to use auto upgrade to ensure that your nodes are always upgraded to match your control plane version. That approach, syncing your control plane version and your node pool version, not only keeping your node infrastructure up to date, but it also mitigates the risk of version skew that we discussed earlier. By now, you may be wondering, why wouldn't I use auto upgrade? It is indeed the recommendation, and while the benefits are clear, you want to ensure business continuity also during times of maintenance. Node upgrades used to follow the workflow of delete and then create. That means that when we do upgrade node pools, we delete one of the nodes from the node pool, and then we bring a new one with the new version. We changed that workflow recently with Surge Upgrade. With Surge Upgrade, we create and then we delete. In other words, we bring a new node with the new version, and only when that node is ready, then we gracefully drain the old node. You can actually control how many nodes can be additionally created for Surge, and also how many existing nodes you are willing to sacrifice for the upgrade process. The combination of max surge and max unavailable also allow you to control the pace of the upgrade, and it actually allows you to accelerate node upgrades, so which can be important, especially if you have large cluster. Um, Donovan, I know that you guys also have very large clusters, and you are using surge upgrade to benefit from more efficiency.
That's absolutely right, Kobe. And it's like you said, we see a great increase in the continuity of the services because they have a place to go when that node gets taken away, as opposed to having no place to go when the node gets taken away. And also, it allows us to do our upgrades faster. We can bring more nodes online and remove nodes as we need to, which greatly reduces. I mean, you think about all the places around the world that companies have to be these days. Dexcom is no different. We certainly have seen great benefits in terms of the amount of time it takes to execute a node pool upgrade thanks to Surge upgrade. We it's great.
And we spoke about the importance of upgrades to ensure business continuity in day two, and also the potential disruption that these upgrades may bring to running cluster. Knowing that different customers have different version management needs, we introduced release channels in GKE with the objective to actually simplify the process of choosing your upgrade path, and also to allow you to control the type of upgrades that you need for your cluster. Think about it this way: some customers may want to use the latest Kubernetes version because they have some dependencies on newer API or capability, or because they have some specific business objectives. Other customers may prefer stability over everything else, over functionality and the freshness of a version. With release channels, and there are 3 release channels: rapid, regular, and stable, you can choose where you want to be in terms of upgrade path. So instead of choosing a specific version, you can subscribe your cluster to a release channel that meets your need, and GKE will take care of the upgrade. The differences between channels are soak time and maturity of the release. So we first introduced a version to the rapid channel, we let it soak, we promote it to regular, we let it soak again, and then eventually we promote it to stable. Um, Donovan, are you using release channels or the rapid or the stable channels in your production environment?
I can't go into specifics on that, but I can tell you that release channels have greatly simplified how we evaluate the upgrade process. Historically, we'd have to kind of pick and choose and study release notes religiously, and now we get a recommendation from Google saying this has had this amount of soak time, and we've looked at it and believe it's the right version for the workloads that you're looking at. So for us, we have some sensitive workloads. We want to make sure that they're using the stable release channel. For other workloads or other environments, maybe we use different release channels that are maybe more aggressive or have newer features so that we can do that earlier in our development cycle.
And it is important to mention that you can unsubscribe a cluster from release channel if you need to do that, and you can also migrate between release channels in some cases. So this is all sound great. You can automate the process. You can configure the nature of the upgrade and control the version maturity. However, Kubernetes upgrade can introduce breaking changes, and they need to be tested and validated in a pre-production environment so that you can ensure business continuity. This is why we are introducing available versions for channels. Each channel will include one default version and available versions. When a version becomes default, auto upgrade triggers the rollout server to promote the default versions and upgrade the control plane first, and then your node pools if you are using auto upgrade. Before versions become default, GKE will make it available in the fleet. Patch versions will be available 1 week before rollout, and minor version, which tend to be a little bit more riskier, will be made available 4 weeks before rollout. We recommend testing available versions on pre-production environment to mitigate business continuity risks and also to ensure that when we do upgrade your production environment, auto upgrade can be completed successfully. You can use the command line that I have in the bottom of the slide to view the default and available versions for the release channel that you are using for your cluster. And sometimes disruption simply cannot be tolerated, right? I mean, there are some peak business seasons or major company events like trade fair. We recommend to set up exclusion window for these events. With exclusion window, you can specify a range of dates in which you want us to completely refrain from any maintenance. You can also set up maintenance windows to say when you do prefer maintenance to happen. That can help you not only improve predictability of the upgrade, but it can be very handy, especially now when people work from home. You might want to ensure team availability and alignment with the working schedule when maintenance actually takes place. Um, Dexcom also have, I assume, major holidays and planned peak business hours. How do you use maintenance and exclusion windows?
Yeah, it's funny you mentioned, working from home and kind of the nature of the situation that we all find ourselves in because, in the olden days we'd want to see people, in the office to manage things, and now with working from home that looks a little different, but we still want to have people awake and available and in their office, wherever that may be, just in case, because it you want to just be online and ready and not waking up. No one likes to wake up in the middle of the night for things like this. And similarly, when it comes to holidays or certain events, we find that, are there times that we would just not want to risk an upgrade just to make sure we provide the best quality of service to our customers? Absolutely. Having that flexibility has been critical for us, and will continue to be critical for us as we continue to grow.
That's awesome. And I think, another recommendation that we already kind of implicitly mentioned several times is having multiple environments set up. I can't stress enough how important and essential it is to have a pre-production environment in place so you can reliably deliver upgrades to your infrastructure and to your software safely and in timely manner. You can think about it in a way that you have testing environments to test out new releases before rolling them out to production. In this case, we recommend subscribing both your testing cluster and your production cluster to the same channel, so you can use the same version between testing and production. In some cases, you may want to consider Canary or even second development environment to test out newer releases using the rapid channel. That will give you an opportunity to stay ahead of the curve by testing out new Kubernetes features or API and basically improve your time to market when those versions get promoted from rapid to regular and then finally to stable. With multiple environments, we also need an efficient way to orchestrate an upgrade workflow across multiple environments. But in order to be proactive about it, you need to be able to predict when an upgrade is scheduled for your cluster. There's a great way to do so. We have GKE release notes that also offer RSS feeds. You can use that. Also, if you are using release channels, each channel offers a separate release note, so you can only subscribe to the updates that's relevant to your cluster. You can use GKE API, specifically get server config, to retrieve the list of available version. These all options are great, but they do require you to pull the information on a regular basis. So you need to be proactive about it. So to simplify this process even more, we are introducing GKE upgrade notification, which will be beta launched later this quarter. Upgrade notification is based on Cloud PubSub. It allows customers to subscribe to upgrade events and get automatically informed about new available versions, and also when the upgrade actually takes place on their cluster. In this case that I have here in this slide, we have a DevOps team using a Slack channel, and new notification is being pushed to their channel, to their Slack channel through the PubSub subscription. And the team this way know about and notified ahead of time about new versions. This way, the team can optionally orchestrate a specific workflow. For example, upgrade their testing environment first, validate the release, make sure that the release is ready to be safely roll out into production environment. So let's put everything together. We spoke about different concepts. A recommended approach to automate and streamline upgrades would involve pre-production environment using the available version that we mentioned before, and upgrade notification that's set up on your cluster that will inform your team when a new available version is ready for them to test and certify. And eventually, a production environment subscribe to a release channel using the default version in that channel.
So we've covered a lot, and if you can believe it, we've actually got more we could cover. But we hope that you've gotten a sense of some of the best practices and recommendations, both from a real world experience as well as from Google and Google's experience managing GKE, to know enough to be really, really dangerous when it comes to running a highly available, really tough, with strict SLOs, SLAs product in Google Kubernetes engine. There are a lot of things on this slide that we could talk at great length about, but we won't for the interest of time. But we also just want to thank you real quick for spending your time with us and getting to hear a little bit about this. And I really appreciate Kobi's time and getting to do this with him. One, because it's just fun, and two, because it's something that I really care about. So thank you, Kobi, and thanks, folks watching at home.
Thank you for tuning in.